Okay, good people, let's continue and calculate the bending moment. Now, let us first mark our beam. We are having A and B. Let's mark this point as our C, then mark this one as our D, and mark this one as our E. Now, we will be therefore calculating bending moment on point A, point D, point B, because bending moment at point C and point E, there's nothing to be bent, then your bending moment there, it is what? It is zero. Now, bending moment at C, bending moment at C, it is at the free end, it is what? Equals to zero. Right. Then bending moment at A. Whether you calculate bending moment at A or whether you calculate it from the left hand side or the right hand side, your answer will be the same and equal. Now, how do we calculate bending moment? Bending moment, it is, we are using the formula, or rather we are using the principle of a moment of a force. It is plus or minus force multiply by perpendicular distance. Why are we saying plus or minus force? In this case, we will be considering the direction of the force. If the force is going up, it will be, the coefficient of that force will be positive. If you are having a force going up, then the coefficient of that force, it will be what? Positive. The coefficient of this force, it is what? It is positive. If it is going down, the coefficient of that force would be what? Negative. The coefficient of this force, it will be what? Negative. This is what we have. It will be negative. Yeah? Those are the principles that we'll be using to calculate the bending moment. Now, bending moment at A, when we are calculating it from the left hand side, we are going to say B, bending moment at A equals to, on this line we are having a downward force, it is negative 20, multiplied by perpendicular distance, the distance from here to there, it is 1, plus negative 5, it's going down, it is negative, negative 5 multiplied by perpendicular distance, the distance from 5 to where we have taken moment at B, it is what? 0, 0,5. Now it will be negative 5 multiplied by 0, 0,5. Then we get our answer as negative 22,5 kilo Newton meter. It is important to write the SI unit of your bending moment, or else you'll be penalized. Now please write the SI unit. Now, in calculating the bending moment at A from the right hand side, we still have to get the same and the correct answer. Let's look at it in applying the given principle, that whether you are calculating it from the right hand side or left hand side, it doesn't matter. If this is where we have taken moment, if we have taken moment here and we are calculating bending moment from the right hand side, on this line I'm having a downward force, it is negative 30, multiplied by the distance from here to there, it is 1, plus 1, it is 2, plus 4, it is 6. Now it will be negative 30 multiplied by perpendicular distance, of which it is 6, plus, on this line I'm having an upward force, and all forces going up, they are positive. Now the coefficient of that force, it is positive. Now I'm having 63,5 multiplied by 5. The perpendicular distance from here to A, it is what? 5. plus, on this line I'm having a downward force, on the D point I'm having a downward force, and all forces going down, they are negative. I'm having negative 30 multiplied by the distance from here to where RA is, it is 4, plus I'm having another force, and this force is a downward force, it is 20, it will be plus negative 20 multiplied by the distance from here to there, it is 2. Then our bending moment at A, the answer would be the same and equal. It is negative 22.5 Newton per meter. Let's punch it. Don't just say it is negative 30 multiplied by 6 plus 63.5 multiplied by 5 plus negative 30 multiplied by 4 plus negative 20 multiplied by 2. Then we get our answer as negative 22.5. It doesn't matter whether you calculate your bending moment from left or right, your answer would be the same. Now, let's calculate bending moment at D. Bending moment at D. Now, always work with an easy side. Now, on this point, the easy side would be from the right hand side. Now, bending moment at D from the right hand side would be, on this line I'm having a downward force and all forces going down, they are negative. It is negative 30. From this point to that point, the perpendicular distance, it is what? It is 2 multiplied by 2 plus, on this line you are having an upward force and all forces going up, they are positive. It will be 63.5 multiplied by the distance from here to D, it is 1. Right, then our answer would be multiplied by 2 plus we get our bending moment at D as 3.5 kilonewton meter. Please write the full SI unit. In my case, writing the full SI unit, it will, eat my time because I'm recording and it will be longer. Now, bending moment at B, bending moment at that RB, bending moment at B, we are working from an easy side. Bending moment here, it will be, on this line I'm having a downward force, it will be negative 30 multiplied by perpendicular distance. Perpendicular distance from E to B, it is what? It is 1. Therefore, your bending moment there at B, it is negative 30 kilonewton meter. Then bending moment at E, it's a free end, there's nothing to bend, therefore bending moment at E equals to 0. Like we said on the principles, that at free end, the bending moment there, it is what? It is 0. Now, this is how you calculate your bending moment. You therefore have to draw your bending moment graph. Now, in drawing your bending moment graph, you need to as well start at 0 and end at 0. Now, bending moment at A, we got it as negative 22. It is below 0. We will be representing it negative 22.5 kilonewton meter. Please write the whole SI unit there. Yeah? Now, bending moment at D, we did calculate it. There it is positive, it is 3.5. Then the fact that you are having the UDL between this line and that line, you will write it as a semi-cycle like, or as hyperbola, or as a slagging or lagging shape there, or line. And between this point and that point, you are having a UDL. You will write it as slagging or lagging. Boom. 3,5 kilonewton meter. Between this point and that point, there's no extra load, and bending moment at B, we did calculate it. There it is negative 30. We will write it as a straight line. Boom. Right. Then bending moment at E, it is 0. Now here, bending moment, it is negative 30 kilonewton meter. This is how you draw your bending moment graph. After you've calculated, then you need to plot your graph. We said it that where shear force it is 0, that's where your maximum bending moment will be. We therefore have to draw, or rather we have to calculate the maximum bending moment, because this is where our maximum bending moment will be, on this line here. This is where our bending, our maximum bending moment is here. Now, that gives me the picture that we then have to take moment here. Like we calculated bending moment at A, bending moment at D, we are now taking bending moment here. Let's denote this point here as F, point F. Let's denote it as point F. Now, let's denote it as point F. Now, this is point F. Let's denote it as point F. Right. Then we have to take moment here at point F and calculate the bending moment there. And please don't forget that on your beam you still have that uniformly distributed load. But here's the thing. We don't know the distance from this point A to point F. We don't know the distance, because for us to calculate bending moment, we need that distance there. Because from this point A to point F, we are having a uniformly distributed load. We have to convert this uniformly distributed load to be a concentrated load. Now, we therefore have to calculate this distance. Can we denote that distance unknown there as distance x? As distance x. We don't know that distance. We have to calculate it. In calculating that distance, we will use an easy route. We will say on this triangle here, with what is your highest force point? Your highest point, it is 16,5. Then you are going to say x equals to 16,5 over the value of your UDL, and the value of your UDL, it is 5. Then your x, it is 3,3 meters. Now our distance, it is 3,3 meters. That distance x, it is 3,3. Then we can now calculate our bending moment where on this point F. Then we have to therefore convert our UDL. We have to convert our UDL from this point to that point. And when we convert, it will be 5, the value of UDL multiplied by that distance, and we put that force at the center of that distance, and in so doing that, our force, it is what? It is 5. The center of 1 meter, it is 0,5, because you will say 1 divided by 2, then you will get 0,5. Then we then have to convert this UDL from point A to point F. In converting, we are going to say 3,3 multiplied by the value of UDL, and of which the value of UDL, it is 5. Then it will be 16,5. Then we have to put that 16,5 in the center. Center of what? Center of this distance from A to F. Then it is what? 16,5. And the center of 3,3, it is 3,3 divided by 2. it is 1.6. Now, the center of that distance, it is 1.65. Then we can now take moment at point F. Now, taking moment at point F, B, bending moment at F would be, if this is where we have taken moment, we will calculate it from the left hand side. Now we are having on this line we are having a downward force, and the value of that force, it is what? It is 20. Then we are having negative 20 multiplied by the distance from C to F, it is what? I'm having 1 plus 3,3, that would be 4.3. Plus, right, plus, remember on this line we still have a force, or let's not forget this 5. Now I'm having a downward force between this line and that line. I'm having a downward force, and that force, it is what? Negative 5. It will be negative 5 multiplied by the distance from where 5 is to where we have taken moment at point F. We know that from here to here it is 0,5. 0,5 plus 3,3 equals to 3,8. It will be multiplied by 3,8. Plus, on this line we are having an upward force, and that force, it is 41,5. Now I'm having 41,5 multiplied by the distance from A to F. The distance, it is 3,3. Plus, between A and F we are having a downward force, it is 16,5. Now you will say negative 16,5 multiplied by perpendicular distance. The distance from 16 to point F, it is 1,65 multiplied by 1,65. Then our bending moment at F would be 4,725. 4,725 or 752. Right, let's quickly calculate it. It is negative 20 multiplied by 4.3 plus negative 5 multiplied by 3,8 plus 41,5 multiplied by 3,3 plus 16,5 multiplied by 1,65. Then we get our answer 7,25 kilonewton meter. Right, kilonewton meter. Now that point F, that's your maximum bending moment. Now the question will say redraw your bending moment graph. Now you will take it from this point and write the broken lines in redrawing your bending, so as to indicate that point F there, and say your point F, it is 4,725. Boom. This is how you calculate this point here. It means you need to take moment at point F. After taking moment at point F, then you calculate that point F. We can as well calculate this point F from the right hand side. You can calculate it from the right hand side. This is how you calculate your bending moment. Then I will drop a video on calculating the BM equals to 0, the point of what? The point of inflation. I will drop the video as well in calculating the point of inflation where BM equals to 0, and calculating their position. I will drop it as well. Thank you, good people.